Hi, good morning to all. In continuation of the last session, now today we are going to extend our discussions to simplex method. Just now I mentioned in the previous session, the first session is meant for to understand how to formulate the available information in the form of mathematical equations by objective functions and the conditions imposed to meet your objectives that we already covered by the first session. Whereas in the second session, once we formulate the inputs in the form of mathematical equations to get the solution, if the number of decision variables are involved to meet your expectations is limited to only two decision variables are plays vital role limited to for decision making to meet your objectives, which is the best solution out of the available resources that can be identified by the graphical method. If we considered, but in real life applications, the number of variables involved for decision making, the number of things involved for decision making is beyond 2. If beyond 2 variables are involved, that is beyond 2 conditions, two decision variables are involved for decision making, we need some extensional procedure in place of the graphical method that can be done by simplex method. It is one of the procedures for decision making by consideration of beyond 2 decision variables. It may be extended any number of variables. So the simplex method is an iterative procedure, that is a step-by-step procedure by which a new basic feasible solution can be obtained from a given initial basic feasible solution, so that the value of objective function is improved. So step 1. So how to solve the problem? Once we formulate the given information in the form of an equations, how to solve the problem? So the solution procedure is explained by stepwise procedures. So step 1, check whether the objective function of the given LPP is maximized or minimized. If it is to be minimized, then we have to convert it into maximization type. Convert it into maximization type, because now we are going to limit by our discussions how to find the solution once we rewrite the objective function in the form of maximization. For that only there is a need of conversion, otherwise no need. So check whether all available resources, that is the BAs, are non-negatives. If any one of the BA is negative, then multiply the corresponding inequation of the constraints by -1, so as to get all BAs are non-negative. Step 3, convert all inequalities of the constraints into equations by introducing slack or surplus variables. What is meant by slack? The RHS and LHS is not balancing each other. The LHS is less than or equal to RHS, that is there is a lagging in between the resources and the maximum availability that should be compensated by adding something. If the converse is there, the resources is beyond the availability, then we have to delete the surplus information. So surplus is nothing but deletion of the information. Slack is nothing but adding together the essential quantities to meet your expectations. And artificial variables in the constraints, put the cost of slack or surplus variables equal to 0 and cost of artificial variables by -1 RM. Depends upon the modified objective function. That is not part of our discussion, just we will introduce. These are the possible resources, how to rewrite and how to proceed further. Obtain the initial basic feasible solution by setting all decision variables is equal to 0 in equations obtained in step 3. Then the next one, step 5, determine which variable to enter. So here different decision variables is there. We have to decide which variable we have to consider initially to get the more to meet your objectives, which are stepwise better to consider to meet your objectives in effective manner. That can be done by simply determine which is to be included in the first phase. Like that can be decided by the following procedure. Determine which variable to enter into the solution list, identify the column, hence the variable with the largest positive number in Cj minus Zj row of the previous table. This step means that it will be producing sum of the product contributing to the greatest additional profit per unit. So the next one is step 6, and in continuation of the last step we have to determine which is to be included. Once we are going to be included something, the system is already existing. The existing information should be excluded to incorporate some additional information. So one, we have to decide which is include, which is to be excluded. That can be done by the following procedures that are explained in the form of step 6. Then followed by step 7, compute the new pivotal row. So which plays vital role for deciding which is to be included further, which is to be excluded further. That can be done by the step 7. This we can understand very easily by the mathematical orientation. So here, this is the problem given to you. How to formulate it we know already. So here also I am limited to 2 variables only, not 3. As I mentioned, the graphical method is limited to 2 variables. Simplex is meant for more also. It is not the meaning of not meant for 2. So to understand easily, as a first problem, I am limited to only the 2 variables for your easiness only. So here, this is the objective function, conditions are given like this. Now here we observed that adding together by additive property should not be beyond 60. So there is a lagging in between RHS and LHS. So first, to solve the problem, we have to rewrite the inequality in the form of an equation. That means adding together by additive property is at most 60 or less. How much it is less we don't know. So that should be adding by the surplus variable, slack variable. The slack variable is by adding S1 units, the RHS and LHS to be neutralize each other. So S1 is to be added, whereas in the second equation S2 units, whereas in the third equation S3 units are added. By this, the inequality is rewrite in the form of an equation. So then followed by, we have to design the table. Basic variables which are additionally added to balance the equations, inequality the equations S1, S2 and S3 for 3 equations. What are the cost coefficients for it? These are the dummy variables for our mathematical constants. So the dummy variable coefficients or cost coefficients are zeros. So here 1, here 0, by the binary digit code both are neutralized each other. So that here we consider their cost coefficients are zeros. Value of basic variables, that means the available resources for the first constraint is not beyond 60, second constraint is not beyond 15, third constraint is not beyond 8. That we will consider as the actual values of the basic variables. And these are the profits gained by promotion of the each units of the goods by production, that are here we mentioned 500 and 450, that we considered as cost coefficients. The rest of the things is zeros by adding 0s1, 0s2, 0s3. Then here the body of the table represents the coefficients of the decision variable 6, 5, 1, 0, 0 and 60. So 6, 5, 1, 0, 0 like this. Here we are completed the button. Now the question is to proceed further, which is to be included, to proceed further, which is to be excluding. The inclusion can be decided by finding Cj minus Zj. That means we know the cost values. How to compute the Cj, Zj value? Zj values can be obtained by each cost basic variable are multiplied with the corresponding coefficients of the decision variables for each equation column wise, that are adding together the product sums, that is 0 into 6 plus 0 into 1 plus 0 into 1. Add together the product of this column multiplied with this column, that gives Zj. So 0, 0 into anything becomes 0. We know the Zj values, we know the Cj values. By subtracting each other, we are getting 500, 450 zeros. Now which is to be included? Highest value of Cj minus Zj corresponding decision variables will be included in the further mathematical computations to meet your objective function. So now I am decided by this 500, 450, rest of the things are 0. Out of the Cj minus Zj values, which is the highest quantity, that should be included in our further mathematical computations by iterative process, that is the step by step procedure. So now I am decided by the size of Cj minus Zj corresponding to x1 is the highest. So x1 enter into the basis. So which is to be excluded from that? The x1 is included. Now we have to decide corresponding to the x1 coefficients corresponding to the value of basic variable. Basic variables are divisible by the incoming variable coefficients column. So 60 by 6, 15 by 1, 8 by 1. By that we are getting the minimum ratios. Minimum ratio is meant for which is to be excluded from our further mathematical computation stepwise to meet your objective, which is to be included. Included already decided. Which is to be excluded out of S1 are excluded or S2 or S3. By finding theta rule, now which is the minimum value of that? the minimum value will be excluded. In place of that, the maximum CJ minus Zj will be included. So that S3 we are going to replace with the x1. That we can understand by the second next table to see. X1 we already decided. X1 is included in place of S3. So these two are changed to see x1. S1, S2. So x1 corresponding highest value is 500. That are considered here as usually cost basic variable. And this is H. And here, which is common for both row and column by determining which is incoming and which is outgoing, that we will call it as key element or the pivotal element. So that means our objective in the further table, this location value should becomes 1. If it is 1, there is no problem. If not, that becomes 1 by division of the same number. The corresponding column values become 0. That we are going to attempt. That means simply we are doing matrix inverse only to see 1. Is it clear? So from this, the rest of all 0, 0s and 1, the same thing we considered. Now our objective is, just now I mentioned, the corresponding column elements becomes 0. How it becomes 0? The corresponding cell value should be equivalent to each other. So that here we observed 1. 1 minus 1 is 0, and then followed by to see 2 and 0. That means original values will be considered upper side. The new column will be taken as lower side. So lower side values are 1 0 0 0. Upper side values are here. Upper side values are 1 2 0 0. So 1 minus 1 0, 2 minus 0 2 0 1. So here we observed 1 0 1 0 1 0 2 0 1 minus 1, because S1 is here 1, here 0, 0 minus 1 minus 1. The same manner we can transform this information so that here this should be multiplied with this value should be equal to this value. So the entire equation multiplied with 6, then this becomes 6 0 0 0 6. So that 6 minus 6 0, 5 minus 0 5 to understand. 0 5 1 0 minus 6 5 minus 6 0 here 6 is there minus 6. Again we will do the same. Cost values into this multiplication of each one. So 0 into 0, 0 into 1, 500 into 1, 500. In the 0 into 5, 0 into 2, 500 into 0. Like this we know how to get the Zj values. Followed by that Cj minus Zj. Again out of Cj minus Zj we identified which is the highest positive quantity. We are not bothered for the negatives. Which is the highest 450. So x2 we are decided to consider. Which is to be excluded? To decide that out of x2 column elements we considered all values of basic variables. Cost coefficient will be basic variable values are divisible by this column 12 by 5, 7 by 2. If anything becomes 8 by 0 is indeterminate, we are not going to find. If it is negative, we are not going to find. So by finding the theta values, 12 by 5 is nothing but 2.2 like this. 7 by 2 is 3.5, which is the minimum 12 by 5. So now I am decided to exclude S1, include X2. That we can understand. X2 is included, S1 is excluded by this theta rule. So again we will repeat the same procedure. By that we are getting the other value. When we attain all Cj minus Zj's are less than or equal to 0, then we attain our objective. So what is our objective function? By this we are getting the value of Z is equal to 5080, and that means 450 into 12 by 5, 0 into 11 by 5, 500 into 80. All together leads to some value that we will consider as Z value, and the x1, x2 values we will consider it as corresponding to this. By that we can conclude here the maximum value of Zn is 5142.86, x1 is equal to 45 by 7 and x2 is equal to 30 by 7. This corresponding x2 is 30 by 7, x1 is 40 by 7, x3 is the dummy variable. Once we are attaining objective, there is no more discussions about the dummy variables. Here I think so we can understand how to get it all. In the similar manner, just for our understanding, another problem is added. Here the number of decision variables are 3. I understand. Here by promotion of x1 units 3 rupees profit, x2 5 rupees, x3 4 rupees. We already observed in the previous slides, in the first slide for formulation, this first machinery is meant for, suppose it works for not more than 8 hours per day. It is suitable for X1 and X2 products only. It is suitable for X2 and X3 but not X1. The third machinery is suitable for all the products. These are the given conditions are given. In the similar fashion, the inequality should be rewrite as the equations by adding the appropriate quantity. So here S1 units are added, S2 units are added, S3 units are added, that are added to the objective by 0 coefficients, we can understand, and that are formulated in the form of a table by the similar fashion to find the following values. To decide highest value of Cj minus Zj is the incoming and minimum ratio is the outgoing. So we decided x1 is incoming, and in place of that x1 is going to be excluded from further mathematical computations. In the similar fashion we can proceed. By that we know how to get the solution for the problem. This is the way, by the each iteration we know very well by the previous table how to proceed further to get the answers for the objective function. This is the way to get the to meet the objective function out of the given constraints that we already identified by the available resources. In future we will assign some more problems for our practice. Students are most welcome to clarify your doubts at any time beyond the class hours times also. Thank you for listening. Bye.